Hello, in this video we are going to have a look at solving trigonometric equations using a graphical method. So we're going to use the shapes of the graph to help us find the solutions to the equations. So let's have a look at this first example where we're being asked to find all values of x in the interval 0 to 360 such that sine x is equal to a half. Now there's a little clue in the question here. It does say values, so I am expecting more than one answer to this question. Now I'm going to start how I would solve any normal trigonometric equation is I'm going to use the inverse of sine, so sine to the -1 in my calculator to find my first value of x. So when I pop this into my calculator, this is going to give me an answer of 30. So this is my first solution in my answer. Now to find any other solutions, I'm actually going to make a quick sketch of the sine curve. Now it doesn't need to include very much detail, just the key points of the sine curve. So I'm not including anything other than the intercepts, and I've got my y-axis labelled as well there. Now, the value that we have just found was x equals 30. And so it was actually this value about here. Okay, so it was when y was equal to a half. Now, what we can notice is if we extend this y is equal to a half along, it actually intersects the curve a second time. And this is our second solution. Now, to find this second solution, we're actually going to use the symmetry of the curve. Now, you might notice that there is a line of symmetry between 180 and 0, right down the middle. So this tells me that the distance from 0 to 30 is actually exactly the same on the other side from 180. So if I was to do 180 subtract 30, I would find this second solution. So my second solution is going to be 180 minus 30. So my second solution is going to be 150. Now I can check my answers by substituting back into the original equation. So I can pop in my calculator sine 30 and sine 150, and I should find that my answers come out as a half. So I'm happy that these are two correct solutions in the interval given. Let's have a look at an example with tan. So tan has a slightly different graph, and in this time we've got the same interval, so between 0 and 360, and we're solving when tan x is equal to 1. So I'm going to start in the same way. I'm using my inverse of tan, so tan to the -1 in my calculator. And that's going to give me my first solution of 45. Now I'm going to make a quick sketch of the tan curve. Now, like I say, it's a little bit different, the tan curve. So it's got asymptotes at 90 and 270. So these are the asymptotes at 90 and 270. And it crosses the axes at 0, 180 and 360. Now the solution that I have just found was when x was equal to 45. So this was about this point here, when the y was equal to 1. Now again, I'm going to extend my line of y across, and I'm going to see that it does intercept a second time. And this is my second solution that I need to try and find. Now, you'll notice with a tan graph that actually the pattern, the period of the graph, keeps repeating every 180 degrees. So in order to find a second solution on this graph, I need to add 180 degrees to my first solution. So in this case, my two solutions are going to be 45 and 225. And once again, I can substitute these into my calculator to check my answers and convince myself that I'm happy that these are the correct solutions in the interval. Now this next question is a little bit trickier because we've got a little extra step to do at the beginning. So we are trying to find all the values in that same interval for 2 cos x minus 1 is equal to 0. Now the first thing I need to do is rearrange this to get the equation in the form cos x equals. So I'm going to start by adding 1 to give 2 cos x equals 1, and then I'm going to divide by 2 to give cos x equals a half. Just like before, I'm going to use my inverse function, so I'm going to use cos to the minus 1 of a half, and my calculator is going to give me my first solution of x being equal to 60. Now my cosine graph is quite similar to my sine graph, that it's a nice wavy shape, but it does have different intercepts. So it's actually got an intercept at 270 and 90, and it's got its peaks and its troughs at 0, 180 and 360. Now the value I have just found on my calculator was x equals 60. So this was about here, and it was when y was equal to a half. Now we use symmetry with the sine curve, and we can actually do the same thing with the cosine graph. It is symmetrical between 0 and 360, right down the middle. So that means that my second solution is going to be symmetrical, but on the other side. So similar to like what we did with the sine graph, we are going to subtract 60 from 360. So this is going to give me my second solution, which is going to be equal to 300. So quick check, does 2 cos 60 minus 1 and 2 cos 300 minus 1, do they equal 0? Yes, they do. So we're happy that both of these solutions are correct.